We have already seen the RC as well as LC emittance functions properties, and there are several number of properties. Now we will see the RL driving point emittance functions properties. So that means how to determine whether a given function is RL function or not. So this is also having 7 properties. So the first one is that the poles and zeros are simple and are located on the negative real axis of the S plane. Fine, I think this is same as that of RC function, right? And the second one is also same. The poles and zeros are interlaced. That means they are not going to be happening or having in a continuous manner. They are alternative. Fine. And the lowest critical frequency is a 0, which may be at S is equal to 0, right? But there for RC function it should be a pole, and the highest critical frequency is a pole which may be at infinity. Fine, right? Then the residues evaluated at the poles of RL function are real and negative, while that of ZRL by S are real and positive. Okay, this is a bit tricky one. So when you get residues at the poles of the given function directly are real and negative, but that of the function divided by S are real and positive. Okay, and with respect to slope of the RL function, when you take d by d sigma of ZRL, it should be positive. Fine. And with respect to ZRL of 0 and ZRL of infinity, and their impedance values at 0 frequency must be less than infinite frequency. Okay, and if you see these, I'm talking with respect to ZRL. Okay, but here there is an important point to note with respect to RL and RC function properties. See, all these properties are specifically told with respect to ZRL, but even though here it is mentioned like emittance function, okay, these first 4 are common because that means they are valid for both admittance as well as impedance. But if you see, these residues are told with respect to ZRL, and this is also the slope property is also with respect to ZRL, and this infinite and 0 frequency values are also with respect to ZRL. That means what about YRL? Okay, so we know that the admittance of an inductor is similar to the impedance of a capacitor, the basic property, and we can say that with that particular property, the properties of an RL admittance are identical to those of an RC impedance and vice versa. It means ZRC of S is nothing but YRL of S, and ZRL of S is nothing but YRC of S. So with this, we can say that an RL admittance can be considered as that of dual of an RC impedance and vice versa. Vice versa means an RC admittance can be considered as dual of an RL impedance as well. Okay, this is an important point to note here. Fine. So these are the properties of RL function. We can see an example here. So if you see this example where they asked like we have to indicate which of the following functions are either RL, RC or LC impedance functions. So it is specifically with respect to impedance function because all are given as Z of S, right? Okay, we will observe the first one. So here this is an RC impedance function because the poles and zeros are on the negative real axis. Fine, they are interlaced because 1, 2, 3. 1 is 0, minus 1 is 0, minus 2 is pole, minus 3 is again 0. They are not continuous, they are alternating, so it is interlaced. And third one is saying that critical frequency nearest to the origin is a pole. What is nearest to the origin here? It is -1, sorry, it is 0. Sorry, s equals to 0 is also a pole, so it is nothing but a pole. That's why it is RC. Okay, that is the main difference between RC and RL. Maybe with that property you can easily observe or get it. Fine. Let us see the part B. So here there is a 0 at s equals to 0, and at -4, at -8, and at -1 and -6 we have poles. So nearest to the origin we have a 0, which is nothing but s equals to 0. Then all other poles are like interlaced, because at 0 we have 0, then at -1 we have pole, then at -4 we have 0, then at -6 we have pole, and then at -8 we have 0. They are like alternating and they are interlaced. And the critical frequency nearest to the origin is 0, so we can say this as a RL impedance function, direct. Fine. It is very straightforward. The main difference is that the critical frequency nearest to the origin, if it is a pole, then it is an RC function. If it is a 0, then it will be RL function. Fine. Like this you can verify any other function. That's it. Thank you.